right? In this lesson, we're going to start graphing polynomial functions using what we've learned in previous lessons, along with a couple new concepts. All right. The first concept that I'm going to introduce you guys to is the concept of an end behavior. All right. So what an end behavior describes is where your graph is going to go as you go to the left or to the right. All right. So let's say I had something like x squared, right? Hopefully we know what that looks like, right? It's going to look like a parabola. It looks something like this, right? And we really don't need to draw anything more than that shape, just because we know that as we go to the right, it's going to go forever and ever up, right? So it's going to go forever and ever this way. And as we go to the left, it's also going to go forever and ever this way, right? So these little arrows right here kind of describe our end behavior. All right, maybe something like an x to the third, right? Hopefully remember what that shape looks like. It's going to look something like that, right? And then these little arrows, I don't need to draw much more than this, because these little arrows are going to describe where the graph is going, right? And you can see as you're going to the left, you're going down, right? And as you're going to the right, you're going up forever and ever, all right? Now, in general, your polynomial functions are going to follow these exact same rules, right? They might change direction depending on the number that is in front of the leading coefficient, right? So, for example, if I had a negative 2x to the fifth, right, along with maybe some other stuff, right? Maybe it's plus something x to the fourth plus something else, something else. I don't really know what that function is going to look like in between, but I do know that because of that negative and because of that odd exponent, that it's going to go up as we go to the left and it's going to go down as we go to the right, right? I don't really know what happens in between, right? It might go something like that, right? I really don't know, but I do know for sure that it's going to go in that direction and in that direction, all right? Well, how did I get that information, right? Let me explain what's on this slide. All right. So we can figure out the end behavior based on the degree of the polynomial and based on the leading coefficient, right? So we can call this the leading coefficient test, right? If you are doing outside research, maybe you need some more practice, right? This is called the leading coefficient test, right? And basically, it's you take the leading coefficient of your polynomial and you want to check if it's an odd degree or an even degree, right? Odd degree polynomials are going to have opposite behavior at each end, right? Think about the odd opposite, right? O goes with the O. So they're going to go in opposite directions. And if A, your leading coefficient, is positive, then it's going to fall to the left and it's going to rise to the right. So what does that mean? As you're going to go in this direction, right, it's going to go down, right? So it's going to go down. And then as you go in this direction to the right, it's going to go up, right? So it's going to rise, all right? Similarly, if A is negative, or if your leading coefficient is negative, then it's going to have the opposite effect, right? So it's actually going to rise as you go to the left, and it's going to fall as you go to the right, all right? Now, even degree polynomials are going to have the same behavior at each end, right? Think about something like an x squared, like we did in the very beginning, right? It's going to have the same behavior. Both ends are pointing up. Whereas if I had a negative x squared, both ends would be pointing down, right? So it's either both up, both down, but no matter what, they are in the same direction, right? So again, if A, your leading coefficient is positive, then both ends are going to point up. And if A is negative, your leading coefficient is negative, then both ends are going to point down. All right. I like to make a little table to kind of remember this, right? The only, I guess, tricky thing about it is that you're going to have just another thing to memorize, right? But let me just zoom in on a little table that I'm about to make. All right. So I'm going to have one of my sides represent the degree, and then the other side represent the leading coefficient, right? If your degree is odd, even, right, those are the only scenarios, or if your leading coefficient is positive or negative, right? If it's odd positive, right, remember odd goes in opposite directions. Odd positive is going to fall to the left, rise to the right, and odd negative is going to go in the other direction. So it's going to rise left, fall to the right. right? Even, remember, even goes in the same direction, right? So they're both going to go up if the leading coefficient's positive, and they're both going to go down if the leading coefficient's negative. All right, so I like to remember this little table. If this is the route that you decide to take, then you would just be responsible for knowing what goes where, all right? But really, it's only going to be one of these four options, right? It's really nothing crazier than this, right? It's really just going to look like this, all right? But that's the concept of an end behavior, all right? Zeros we've talked about before. I'm not going to spend too much time on that. It's just where f of x is equal to 0. And based on the previous lesson, right, in section 3.4, you guys are now able to find all of the zeros of your polynomial, no matter if it's factorable, or I'm sorry, whether or not it's factorable, right? Multiplicity is the new concept that might be a little bit strange, right? So think about this, right? Let's say I gave you a polynomial x minus 1 squared times x plus 2, all right? Well, if I asked you to find the zeros of this polynomial, right, it would be pretty easy, right? All we would have to do is set this equal to 0, and because it's already factored for us, all we have to do is set each factor equal to 0. So I get an x minus 1 squared equals 0, and an x plus 2 equals 0. All right? Now, x plus 2 equals 0, all you have to do is subtract 2, and you get x equals negative 2. But x plus 1 equals 0, right? We don't really want to write this down, but what really this means is it means x minus 1 times x minus 1. And then you would be setting both of these equal to 0. So we would get x minus 1 equals 0 and x minus 1 equals 0, right? But the point that I'm trying to make is that we get that answer twice. So I get x equals 1 and x equals 1. All right? Now, we would really have 3 answers here, but one of them shows up twice. Now, the one that shows up twice, right, I told you guys that you only need to write it once, but some information hidden, if you were to only write it once, is that you're not accounting for the multiplicity, right? And the multiplicity, in this case, I'm going to say x equals 1 has a multiplicity of 2, right? Now, to put this in language that you guys understand, right, I'm going to say x equals 1 appears twice. All right, x equals 1 appears twice. All right. Now, this actually has meaning on a graph, right? Because if I were to graph this particular polynomial, right, I know for sure that I would have an x-intercept at 1 and then an x-intercept at negative 2, right? But think about what we learned in the previous lesson. If I have 3 answers, then that's an odd degree polynomial, meaning that my end behavior, one end is going to go down and this end is going to go up, all right? Now, to figure out what happens in between, right, keep in mind that x equals 1 has a multiplicity of 2, right? So now let me actually touch on what's actually on the slide here, right? If a root occurs more than once, then the multiplicity is the number of times that a root occurs. And if it's even, right, so if it occurs, like if it appears an even amount of times, then it hits the x-axis and turns at that point. If it's an odd amount of times, then it crosses, right? So think about this. X equals negative 2 appeared once. So this one has a multiplicity of 1, right? And 1 is an odd number. So at negative 2, I'm going to cross. I'm going to cross that point right there, all right? But I'm going to have to touch and bounce back at x equals 1 because x equals 1 has a multiplicity of 2, right? And 2 is an even number, right? And like it says in our notes, an even multiplicity means that you're going to touch it and bounce back. So really, there's going to be like this little bounce right here, right? So we're going to figure out later in this lesson what actually happens in between these 2 points, right? It might go super high up like that, or it might go pretty low like that. But what I can say for sure is that it's going to bounce at this point, right? So this is a rough sketch of what a graph of this would look like, right? And we use the multiplicity to kind of determine what happens at the x-axis. So I know it has an x-intercept, and a 0 because that's what we found when we set this equal to 0. But the multiplicity is just going to tell you the behavior at that value, whether it touches or crosses. All right? And that's essentially the information that we get from a multiplicity. All right? So for something like this, it's not asking us to graph it. I just want to find the end behavior, the zeros, and the multiplicity. All right, so let's start with the end behavior. All right, so we look at the degree. All right, it's an odd degree. And the leading coefficient is positive. Positive leading coefficient. All right, so what does this tell you? This tells you that it's going to maybe look something like that. All right, and for the sake of this class, all you really need is an arrow description, right? Seems really not technical, right? But that's perfectly acceptable for the sake of this class, right? This represents your end behavior, right? That would be your answer, all right? Or if you want to write it in words, you can say that it falls left and it rises right. All right, so that's also an acceptable way to phrase your end behavior. All right, now let's find the zeros. All right, now this one's actually factorable, so what I'm going to do is I'm going to group. So it's going to be x to the third plus 2x squared, right, and then minus 4x minus 8 equals 0, right? Take out an x squared, and you're left with an x plus 2. Take out a minus 4, and you're left with an x plus 2. And so we end up with an x squared minus 4 and an x plus 2 equals 0. So then we get x squared minus 4 equals 0 and x plus 2 equals 0. And so I get x squared is 4, square root both sides, and I get x is plus or minus 2. All right, subtract 2 on both sides, and I get x equals negative 2. All right, so listing out all of our zeros, I get x equals 2 and x equals negative 2 from the plus minus, and then I got an x equals negative 2 from that right there, from this little one that we found earlier. All right, so those are our zeros, and now I want to state the multiplicity. And remember, the multiplicity just represents the number of times that a solution shows up, right? So the solutions that we have are x equals 2, right? And x equals 2 appears once, so I'm going to say this has a multiplicity of 1, right? Now, we're not graphing, but I'm just going to, for the sake of your notes, I'm going to make a note that this is going to cross at the x-axis. Why does it cross? Because 1 is an odd number. So it's going to cross at the x-axis. And then the other answer that we got is negative 2, right? Count your solutions. How many times does negative 2 show up? All right, 1, 2, right? It shows up twice. So it has a multiplicity of 2. All right, and what does this mean in terms of our graph? It means it's going to bounce at the x-axis, and it's not going to cross it. It's just going to touch and bounce back. All right, so that is plenty of information to actually graph our polynomial, and you're going to see that as we go through some examples. Right, this particular lesson has a lot of examples, and they're each pretty lengthy, so I'm not going to do all of them, right? But we're at least going to do a couple just so that you guys can get used to the idea of graphing and using this information that we found, right? The multiplicity and the end behavior and the zeros, right? In order to graph your polynomial, right? Because all of this is going to tie together nicely. All right. So some strategies to actually graph our polynomials is we would need to determine the end behavior. So I want to know what happens as you go to the right and to the left. I want to find the zeros and the multiplicity, right? We want to know where it's going to cross our x-axis and the behavior at the x-axis. We want to find the y-intercept just to make sure that we're graphing that point accurately. And then we maybe need some additional points, right? So we might be able to get a rough sketch with just this bit of information, all right? But additional points is only going to make it more accurate, right? So sometimes we might even ask you on a test or a quiz, right, to plot additional points just to make your graph a little bit more accurate, right? But majority of times, these first 3 bullet points are enough to kind of get a rough idea of your graph. The additional points just solidify it and make it more accurate, right? More precise. All right, so let's actually put all of this into practice. All right, I want to graph this polynomial function using what we've learned in this lesson, right? And what did we learn in this lesson? We learned about end behaviors and multiplicity, right? Those are really the only new things that we learned in this lesson, right? We learned about the zeros, right? I would honestly start there, right? So the first thing that I would need are the zeros, right? I want to make sure I'm plotting those points on my graph. So to find the zeros, I'm going to have to do synthetic division, right? Because this is not factorable, right? And remember that if it's not factorable and you're not given any factors, what you have to use is the rational root theorem, right? And the rational root theorem that we learned in the previous lesson states that we need positive and negative factors of the last over factors of the first, which in this case is going to be positive and negative 1, 2, 3, and 6, right? So these are the options that we have to choose from. All right, let's try 1. All right, so I'm going to have a 1, negative 2, negative 5, and a 6. I'm going to bring down 1, then I get a 1, negative 1, negative 1, negative 6, negative 6, and 0. All right, so x equals 1 is one of our zeros. All right, I'm going to go ahead and plot that point on our graph. All right. Now with what's left over, I'm going to make a quadratic equation. So x squared minus x minus 6 equals 0. And this is factorable. This is going to get us an x minus 3 and an x plus 2 equals 0. So I get 2 more zeros at 3 and negative 2. All right. So we have 3 zeros. So 3 intercepts. I'm going to plot those points now. All right. Another point that we want is the y-intercept, right? So the second thing that I would maybe look for is a y-intercept. So plug in 0 for x, and it's always going to be your constant value. So if you remember from lesson 3.1, I had told you guys that your c value is always going to be your y-intercept, and that's true for any polynomial equation, right? The constant term at the very end, every time that you plug in 0, all of these are going to cancel out. So f of 0 is 6. So that means our y-intercept is 0, 6. All right, I'm going to make this graph go by 2s, right? So 2, 4, 6, right? So I'm going to plot a point right there. All right. Another thing that we need after our intercepts are the end behaviors. All right, so end behavior. And in this case, since it is odd and positive, right, this means that it's going to go down as you go to the left, up as you go to the right. So at our very left x-intercept, I'm going to draw that graph going down like that. At our very right x-intercept, I'm going to draw that graph going up, right? It's just what happens in between that we aren't too confident of. All right, so I'm going to pick additional points. All right, so pick additional points. So some additional points I can maybe pick, maybe like negative 1. So let's try negative 1. I'm going to use remainder theorem to find some additional points. All right, you could just plug it into your function, but I think we are getting into the groove of using synthetic division, so hopefully we're getting a little bit more comfortable with that. All right, so at negative 1, I have a value of 8, and that's going to be up here. All right, and maybe I want to know what happens between 1 and 3. All right, so let's try 2, positive 2. All right, so 1, negative 2, negative 5, and 6. All right, just to get a rough idea of what our graph is going to look like. All right, so negative 4, right? It's going to end up right there. All right, and I think that's enough points to graph our polynomial function, right? It's going to maybe look something like that. All right, so that's a good idea of our graph. All right, really somewhere in these steps, I would say even with the zeros, I would also include multiplicity. all right? And in this case, all zeros in this case have multiplicity of 1. Have multiplicity of 1, right? So what does this mean, right? This just means that we're going to cross at the x-axis. All right, if any of our answers showed up twice, then you would have to bounce, right? Touch and bounce at the x-axis, right? But you can see at these x-intercepts, we're crossing, right? And this is enough information for our graph. All right, let's try the same exact thing with this one. All right, so again, the first thing I want are my zeros. All right, so the first thing I want, zeros, I would need a list of possible ones, right? Because this one's not factorable. So it's going to be plus minus factors of 12. So 1, 2, 3, 4, 6, and 12 over factors of 2, which are 1 and 2, right? You don't really need to list every single one of them, right? Unless we ask you to on a test or a quiz, you don't really need to list all of them, right? I think it's pretty safe to say that 1 is a valid pick, right? So let's start with that one, right? Let's just see if 1 works, right? And then I have 2, -1, -25, and -12. All right, let's just see if this works. 2, 2, 1, 1, -24, -24, that doesn't work. All right, so let's erase. Let's try -1. All right, so 2, -1, -25, -12. So bring down 2, -2, -3, 3, -22, and 22. That also doesn't work. So let's try maybe 2. All right, 2 is in our possibilities. So let me bring down that 2. It's going to be a 4, 3, 6, -19, and then you can see that that's not going to work. All right, that's going to get you -38, and that doesn't get you 0. All right, so let's try -2. All right, 2, -4, -5, 10, -15, 30, and that doesn't get you 0. Great, let's try 3. All right, so you can see this process gets pretty tedious. Right? So 2, 6, 5, 15, -10, -30, that's not going to work. So let's try a -3 now. All right. So let's just see, right? 2, -6, -7, 21, -4, 12, and 0, right? So this one does work. So that means x equals -3 is one of our zeros, right? And now with 2, -7, and -4, I'm going to put those into a polynomial, and we're going to try to factor this. All right, so 2x squared minus 7x minus 4, I can do 2 times -4, and that's going to make -8, right? And I need factors of -8 that add to -7. So -8 and a +1. So I'm going to get an x minus 8 and x plus 1 equals 0, right? I want to divide by 2, right? So then I get x minus 4 and the 2x plus 1 equals 0. So we get x equals 4 and x equals -1/2. All right. And all of these have a multiplicity of 1, right? So I'm going to say all have a multiplicity of 1, right? So we're going to cross at the x-axis. All right, so none of these are going to bounce. I'm just going to go ahead and label this. All right, so I have a -3, a -1/2, which is somewhere right there. And then I have a 4, right, which is going to be right there. All right. I want to know what my y-intercept is going to be, and to find my y-intercept, since this is a since this is a polynomial in standard form, I'm just going to use my constant, right? So my y-intercept is going to be 0, -12. Again, I maybe go by 2's, right? So -2, -4, -6, -8, -10, and -12, right? And then I'm going to plot a point right there. All right, I want to know what my end behaviors are going to be. So end behavior, since this one is odd, right? It's an odd degree and it's positive, right? This one's going to be down and then up. So that means at my zeros, I'm going to draw an arrow going down and draw one going up. It's just in between that I want to know what happens, right? And since all of these are going to cross, I know that I'm going to make a rough sketch. I know for sure I'm going to cross at all of these, right? We're not going to bounce back, right? I just want to know how high or low we go, right? Because really we can get like kind of a rough sketch already, right? I can say that it maybe looks like that, and then it might look like that, maybe something like that, right? So that's like a rough sketch of what it might look like, right? But to make sure that it's a little bit more accurate, I want some additional points. And so I want to pick some additional points. Let's pick, I want to know what happens in between these two zeros. All right, I want to know how high this goes, so I'm going to pick -2. All right, so let's pick -2, and then we do our synthetic division with the original. It's going to be a 2, -1, -25, -12, which I think somewhere down the line we already did that, right? But let's just try it again. Hang on. Sorry, 2, -1, what is that? -25, -12. Okay, so we get a 2, -4, -5, 10, -15, 30, and 18, right? So at -2, we go all the way up to 18, right? And if we're going by twos, 2, 4, 6, 8, 10, 12, 14, 16, 18, that's going to be somewhere right here. All right. At -2, that's going to be like, I don't know, right there. All right, so you can see that it actually goes pretty high. All right, and then maybe it even goes higher after that, but this is a good rough estimate of how high it's going to go, right? And now I kind of want to know what happens between these points right here, right? Maybe I want to pick like 1, right? 1 looks like it's somewhat in the middle between those two, right? 1 was actually the very first number that we checked, right? So if you still have your work, you didn't erase it, then you could just look back, right? But I'm going to use 2, -1, -25, and -12, right? So 2, 2, 1, 1, -24, -24, and then -36. Right, so this actually goes all the way down to -36, and that's going to go way off our graph. So you can see that it's actually going to go way down here. All right, probably something like that. Maybe even goes a little bit further, but at some point it has to come back up. All right, so let me go ahead and erase a little bit of our graph right here, just get rid of our scrap work. All right, and then fill in the rest of it. All right, so it's going to look something like that. All right, and then that's the graph of this function, right? You really could have gotten, like I said before, the rough estimate without using the additional points. But by using the additional points, it only gets more accurate from there. All right. But that's in general the process, right? Hopefully you guys are seeing that everything's tying together pretty nicely, right? Things that we used in previous lessons are appearing now, right? Everything has the sole purpose of solving polynomial functions. All right, let's try another one like it. So again, I first want to find my zeros, right? And some possible rational zeros are going to be plus minus factors of 20. So plus minus 1, 2, 4, 5, 10, 20. All right, over plus minus factors of 1. So over 1 is just going to be the factors itself, right? So let me go ahead and erase that. It's just going to be these. So let's pick, right? I'm going to pick 1. All right, so it's going to be a -1, -8, -11, and 20. All right, bring down -1, -1, -9, 9. I'm sorry, -9, -20, -20, 0. It works, right? So I get that x equals 1 is one of my zeros. I'm going to plot it already, right? So we got kind of lucky there. All right, now let's do -x squared minus 9x minus 20 equals 0. All right, I'm going to get rid of that negative, divide by -1. And then we get x squared plus 9x plus 20 equals 0. This is factorable. This is going to get us an x plus 5 and an x plus 4, and then we get x equals negative 5, and we get x equals negative 4. So I'm going to go ahead and plot those, right? Negative 4, negative 5. All right. And all of these have multiplicity 1, right? So all have multiplicity of 1, and this just means that it's going to cross at the x-axis, right? I want to know what a y-intercept is going to be, and our y-intercept is going to be that last number, right, as an ordered pair, 0, 20. All right, I'll go by 4s this time, right? I'm going to do 4, 8, 12, 16, 20, right? And there's our y-intercept. All right, so I'll plot that there. All right, I want to know what my n behaviors are, right? So n's behavior, since this is odd negative, it's actually going to be the opposite of what we did in the previous 2 examples. So it's going to go up and then down, right? So at my n behaviors, I know it's going to go up, and then here it's going to go down, right? And I know because of my multiplicities, I know I'm going to cross. So I know at some point I'm going to have to go down and then back up and then down here, right? So then I just want to kind of fill in the gaps, right? I know for sure it's going to kind of maybe go something like that. It might go something like that, and then it'll have to come back down, right? So this really is a rough estimate of our graph, right? If you stopped here, this would be somewhat accurate, right? But to make sure that it's fully accurate, right, let's pick some additional points, right? So between negative 4 and negative 5, right, you could pick a fraction and do synthetic division with the fraction, but we can see that these 2 points are really close to each other, right? We can kind of, it's pretty safe to assume that it's gonna kind of dip back up somewhere in this region, right? You could probably verify that if you wanted to. Maybe it goes way down, right? Maybe it goes like way down there, right? But it's fine for the sake of this example, right? We don't really want to do synthetic division with negative 9 over 2, right? That's going to be kind of tedious, all right? So let's try something in this bigger gap, right? So it's pretty safe to assume that we can have a small dip like this, but between these 2 zeros, I really don't know what's going to happen, right? It could go way up like that, or it might just be a really narrow bounce like that. All right, so let's test a value, right? Let's say like negative 2. All right, let's pick negative 2, and then we're going to get negative 1, negative 8, negative 11, and 20, right? And let's see what this gets us. All right, so it's going to get us negative 1, 2, negative 6, 12, 1, negative 2, and 18. All right, so at negative 2, I'm going to have a point somewhere right, let me see. 18 is going to be somewhere right there. Okay, so I'm a little bit off. Let's actually see what happens somewhere else, right? This is a little different than what I thought it was going to be, right? So let's try maybe like negative 1. I want to see what happens there. So let's try negative 1, right? So negative 1, negative 8, negative 11, and 20. And then let's try negative 1, 1, negative 7, 7, negative 4, 4, and 24. Right, so it actually goes up here, right? So it's going to go somewhere right there, right? So it's actually going to look maybe something like that. All right, not the prettiest graph, right? But might maybe look something like that. All right. And of course you can pick more, right? You can maybe pick negative 3 to see, right? Why don't we do that, right? Negative 3. If you're content with this graph, you can feel free to move on, but I'm not really satisfied with how this looks right now, right? So I'm going to do 3, negative 5, 15, we get 4, negative 12, and 8, right? So at negative 3, it's actually going to be right there. Okay, so kind of close to what we have, right? It's going to look maybe something like that. So maybe here it's actually less of a dip, right? It's probably going to come back up a little bit sooner, right? It's not really going to have like sharp curves anywhere, right? It's probably going to like these polynomial functions, right? And you can verify, right? If you use a graphing calculator or Desmos or something like that, you can see that they're not going to be like super harsh curves, right? They're going to flow pretty smoothly, right? So it might look something like that. All right, not the prettiest thing in the world, but it's the best we can do for now, all right? Right, this is another third degree polynomial, right? I'm actually going to skip through some of these. I want to find something maybe a little bit different. All right, I'll try one like this. So this one's a little bit different just because it's already factored for you, right? We don't really need to do rational root theorem or anything. We already have the factors, right? So all I have to do is set all of these equal to 0, right? I'm going to get a negative x minus 3 squared, x plus 1, and x, I think that's a typo, all right? Let's just say for the sake of this, I'm just going to pretend that this was x minus 1, right? Let's just say this is x minus 1. Let's see what that does to our graph, right? And then x plus 1 squared, all right? Now, when we set this equal to 0, all I have to do is set all of my factors equal to 0, right? Let's divide this by -1 to get rid of the negative, and then let's set all of our factors equal to 0. So I get x minus 3 squared equals 0. I get x minus 1 equals 0. And then x plus 1 squared equals 0. All right, notice here that x minus 3 squared, that's really the same as saying x minus 3 times x minus 3 equals 0. And really what we get is we get x equals 3 twice. So this x equals 3 is going to have a multiplicity of 2. And what does a multiplicity of 2 mean, right? If it's an even number, then it's going to bounce at the x-axis. All right, let's do the same thing over here, right? X minus 1 equals 0, then x would equal 1. Right, this one only showed up once, so this one's going to have a multiplicity of 1. So this one's going to bounce. All right, and let's do the same thing with this one, right? X plus 1 squared equals 0. Remember that squared is the same as x plus 1 times x plus 1. And really, we have two factors, and they're both x plus 1. That means x equals -1 twice, right? So this one's going to have a multiplicity of 2, right? And this one is, oh, sorry, I misspoke in the other one. This one's going to bounce, and that means this multiplicity of 1, because it's an odd number, right? That was a mistake, guys, right? This is going to cross, right? Odd multiplicities cross, even multiplicities bounce. So let me go ahead and plot those on our graph. All right, so I'm going to have a -1 here, a 1, and a 3. All right. Now, what I want to know is I want to know what my end behaviors are, right? It doesn't look as easy as the other ones when determining your end behaviors, but keep in mind, the end behavior is just going to be however many x's you have multiplied with each other, right? So let's say I were to FOIL this out, which you really don't want to do, right? But let's say I were to fully FOIL this out and I get an x minus 3 times x minus 3. Then you would have to FOIL this and you would get an x squared. Then you would do that x squared times that x right there, and that'll get you an x to the third. And then it'll be x to the third times 2 of these x's, right? If you were to keep doing that, let me erase that, right? If you were to keep doing that, you would end up with 5 x's total, right? And if you're not okay with that, right, just count the number of zeros that you have, right? I had x equals 3 twice, right? So that's 2. I had x equals 1 once, so that's 1. And I had x equals -1 twice, that's 2. The number of zeros you have is always going to correlate to the highest exponent, right? So if all of your zeros are 5, then this is your degree, right? And so it's an odd degree, and because there was a negative in the very front, then it's going to be negative, right? So this is an odd negative end behavior. So it's going to go up and then down, right? So let me separate this a bit, right? I'm going to say that this is my end behavior, all right? So we found our zeros, we found our multiplicities, we found our end behavior, right? Let's try to find a y-intercept now, right? Again, not as easy as the other ones because this time I actually have to plug in 0. And when I plug in 0, I get a 0 minus 3 squared times 0 minus 1 times 0 plus 1 squared, right? And this is going to get me -1 negative 3 squared times negative 1 times 1. And this is just going to get me a negative 1, and negative 1 times negative is going to cancel out. So this is just negative 3 squared, which is 9. All right, you can do that a little slower if you need to, but for the sake of this lesson, it's already a little bit lengthy, right? I'm going to do 0, 9 as my y-intercept. All right, and then I'll graph these by, I'll probably do like by 2's again, right? So 2, 4, 6, 8, 10, and then I'm going to have a y-intercept right there. All right, and I'm going to use my end behaviors, my intercepts, and my multiplicities to kind of sketch the graph of this function, right? So because I know that it's going to be up and then down, then I know over here I'm going to have to go up at some point, and then over here I'm going to have to go down at some point. All right? And because my zeros of x equals 3 and x equals negative 1 have multiplicity of 2, I know that here I'm going to have to bounce back. And then here I'm also going to have to bounce back. Right? But because x equals 1 had a multiplicity of 1, I know I'm going to have to cross here, right? So then I'm going to go up, cross my y-intercept. I know eventually I'm going to have to come back down, and then I'm going to have to go down and then come back up and then bounce back, right? So it looks kind of something like that, all right? And then in this case, to pick additional points, you can't really use your synthetic division unless you FOIL this out completely. So just for the sake of this lesson, I'm just going to keep it like that, right? You really could also just plug in 2, right? Let's say I wanted to test where I want to know what happens here, right? I want to know how low it goes. You really could just plug in 2, right? I'll try that for you guys, but I'll say that it's pretty safe to say that you guys don't really have to do this, right? Unless we specifically tell you to, but I don't think it'll be that big of a deal, right? So let's plug in 2, right? Let's see what we get when we do this, right? 2 minus 1. Right? I had changed it in the beginning, right? I changed that to a minus. Right, so 2 minus 1 and then 2 plus 1 squared. All right, and this is going to get us a negative 1 squared times 1 times 3 squared. And then that's going to get me a negative, those cancel out, a negative 9. Right, so it's actually not too bad, right? Negative 9, again, I'm going by 2's, negative 2, negative 4, negative 6, negative 8, and negative 9 would be somewhere right there, right? So kind of close to what I originally put. All right, so it's probably going to look something like that. And then probably go back down at some point right there. All right, but that's the rough sketch of our graph. All right, and a lot of these examples get fairly repetitive, right? It's the exact same process every time. We'll do more practice together in class, and you guys also have plenty of practice in your homeworks and in your quiz and test reviews. All right, so we'll do more practice again together, but hopefully you can also just look through this lesson and see and just see what you can do, right? But really that covers majority of the lesson, right? This video is already kind of lengthy, right? But yeah, that covers all of chapter 3 now.